Yeah, so this is like an industrial robot. This is what's called a pick and place robot, because what it does is it picks up something and places it in another location. So it may have it pick something up off a conveyor belt, put it in a machine that does something to it, cuts parts on it, so on. But basically it's a robot that picks stuff up and moves it to another place.
Or a company like Amazon might use it to pick stuff off a shelf, something similar,
right.
Place it on a conveyor belt, to ship it.
Exactly.
Walmart or whoever.
So basically this program on the computer tells it to go to this point, then go to the next point. Pick it up, close the gripper, go back here.
Uses just the right amount of pressure, it doesn't crush the object, it's able to pick it up without crushing it.
And then go grab another piece. So one of the types of robots you get to learn how to program. And then that's all I have in here, so we'll go out to the main room here. So this is our CNC milling machine. Another thing you learn in computer-aided manufacturing, how to write programs to basically make parts in the CNC machine. We start out learning how to program by hand. Basically, one of the first projects is to write your initials in a block. So basically, you have to learn how to tell the milling machine to go to this point, turn on the spindle so it starts cutting, go down, go across, go back to make a T, and come up, go over, do the next piece. So you learn how to do that. Once you know how to write the program yourself, we go on into CAM, which is computer-aided machining, and it's basically where you have a basically you take your part in Inventor and you basically use a program to write the program for you. So for example, anybody recognize this? It's a Aston Martin symbol. This is one of the students' projects last year. Basically, he drew this all up in Inventor, and you use the CAM software to process it, and basically it writes all the program for you. So it tells the machine where to go to cut this out. This is something that's like, 10,000 lines of code. So you have the program basically do it for you. So it writes all that for you, put it in the machine, tell it to go, and you learn how to set up everything, but you tell it to go, and it cuts out the block for you. And then next we'll go over to the 3D printer. You want to just kind of go down that way.
Hey, I can do that. Yeah, see the machine? Yeah. It's a lot of money. It's like $12,000
Yeah, much cooler.
This makes
So can
I know. You just recorded me. Just delete that, bro.
I'll edit.
Alright, so this is our 3D printer. We use it for various projects, both for projects for class or for just if you want to make something of your own design. Some of the things that we've done is like a little knight head, River Ridge. Another student designed the Enterprise. Here you watch Star Trek. and then basically you make it an inventor. You save it a certain way, bring it over to the 3D printer, do a few setups, and basically it just prints it all out just however you have it designed in Inventor. So basically we can make anything with this. So let's go ahead and we'll go out over to this area over here by the sink. We'll kind of come out from here.
My friend's mother made that. See Zachary in the blue? In the blue, he's my friend's.
Blue jacket?
Yeah. He made this.
The blue jacket?
Yeah.
He's gonna make it float. He's gonna make it float.
And then the other thing we have for engineering students is Royal Robotics. It's basically a team that meets after school, and we build robots to compete in different robotics competitions. So some of you will be learning VEX. I think we'll be learning VEX next semester. So VEX is basically a robotics kit, and we compete in. Well, first off, you do some VEX in the middle school, and then we do more VEX in Principles of Engineering, which is our second year class. But then we also compete in the VEX robotics competition. Where basically, they give you a certain game that your robots have to play. And so last year it was you had to stack these blocks on poles that were about this tall. And so that's our old robot up there. Like you grab these blocks and stack them up. And then this year we played a game that's kind of like basketball, where basically you have these balls here, and you can either score them in a low goal, or you can throw them into a high goal or a hoop. The red goal is over there if you want to see what you have to shoot it into. And basically, what?
Can you shoot it?
Yeah, I can shoot it. So this is one of the robots both of these robots play the game this year. This is kind of a simpler one that just dumps it in the low goal. And then this is our shooter that actually can shoot the balls like 15 feet into the goal. It's a VEX controller. It communicates with the robot wirelessly. Let's see if I know how to do this. I don't drive it too often, so. It picks up balls down here with a certain set of motors, and there's another set of motors that drive lift to pick the balls up and feed into these wheels here. These wheels spin around like 20 times a second and basically shoot the ball out. So now then, if you want to kind of stand outside, not in front of it.
No, I want to get that. Put it in the ball. Yo, put the ball in there. Put the ball in there.
Okay, I'll get to that. So this robot can make full court shots. So basically, you can shoot all the way. The court's about the size from here to that basket in square. Or it's programmed so you can set it at lower speed, so you can shoot it basically from anywhere on the court. You can shoot it into the goal. You don't have to be at full court. You can slow it down. We also do
But they use, like,
fighting
the little,
robots. I don't have
Hershey.
any of those out right now, but basically we also do like BattleBots. If any of you have seen the BattleBots show, we do that and compete in local competitions for that. And then we also have our. How many of you have seen Gopsy?
What's Gopsy?
The T-shirt cannon.
Oh yeah.
T-shirt guy.
So this is our T-shirt cannon robot. Basically, you can put a T-shirt down the barrel here, ram it down, and there's a valve here that holds back 120 psi of pressure. That when you push a button, it shoots it out and basically can